All right, let's talk about Kubernetes. That technology that's quietly running pretty much everything you use online. Ever wondered how apps can just work no matter how many people are using them? Well, we're going to pull back the curtain and break down exactly how it works. Let's dive in.
Okay, so you've nailed containers, right? You've packaged your application up into this perfect little box that runs the same way everywhere. That's a huge win. But here's the catch. That's just for one container. What happens when your app totally blows up? Suddenly you don't need one, you need hundreds, maybe thousands. How in the world do you manage all of that?
And that is where everything changes. See, on your laptop, a single container, it's a piece of cake. That whole "it works on my machine" nightmare is finally over. But in production, production is a completely different beast. We're talking thousands of containers, all needing to talk to each other. It's organized chaos, and you need something to bring order to that chaos.
This is exactly what people call the 1,000-container problem. And the big question becomes, how do you manage all of this complexity without everything just crashing and burning?
The best way to think about it is like an orchestra. Each one of your containers is a brilliant musician, playing its part perfectly. But if you throw 1,000 brilliant musicians into a room with no conductor, you just get noise, right? You need a conductor, someone to tell them when to start, what to play, and, what to do if the first violin suddenly passes out.
Well, that conductor, that's Kubernetes, or K8S as you'll often hear it called. It is the platform built to automate all the really, really hard stuff about running containers when you've got a ton of them. It handles deploying them, scaling them up or down, and just managing them day to day. It's the brain of the whole operation.
Okay, so we've got our conductor. But how does it actually do all that? To really get it, we need to look inside the machine, at what's called the Kubernetes cluster. At a high level, a cluster is broken into two main parts. First, you have the control plane. Think of this as the brain. It's where all the big decisions get made. And then, you've got the worker nodes. These are the muscle. They don't do the thinking, they just do the actual work, the heavy lifting of running your apps.
So let's start with the brain, the control plane. This really is like the mission control for your entire system, and it's made up of a few key players that all have a very specific job.
So imagine you give Kubernetes an order, like, hey, run 3 copies of my app. That request first hits the API server. That's the front door. The API server takes your order, what we call the desired state, and writes it down in this special database called etcd. Think of etcd as the cluster's permanent memory. Next, the scheduler kicks in. Its only job is to find the best home for your app, like a real estate agent finding the right worker node with enough space. And the whole time, the controller manager is watching, constantly comparing what's actually happening out there with what you said you wanted in etcd. Okay, so the brain has made a decision and sent out the orders. Now let's jump over to the muscle, the worker node, and see how the job actually gets done. This is where your code finally comes to life.
Now, here's a super important detail you have to get. Kubernetes doesn't actually work with containers directly. Nope. It manages something called a pod. A pod is the absolute smallest, most basic unit in the Kubernetes world. You can think of it like a little shell or a wrapper that holds your container.
This is one of those concepts that if you get this, you're halfway there. Let's go back to our orchestra analogy. The container is the instrument, say the violin. But the pod is the musician holding the violin. The container is just the packaged up code. The pod is the living, running instance of your application. That distinction is everything.
So how does a worker node pull this off? Well, it has a few little helpers running on it. There's the kubelet. That's the agent that's always listening for orders from the control plane. Then you have kubeproxy, which is basically the network plumber, making sure all the traffic goes to the right places. And finally, the container runtime. This is the engine itself, the software that actually runs the containers inside the pods.
Okay, we've met the brain and we've met the muscle. Now let's put it all together and see this whole system in action. Because this is where the real magic happens.
Let's take a really common scenario. We tell Kubernetes, hey, my goal is simple. I want you to make sure there are always 3 running pods of my app. No more, no less. That's our desired state, and it gets written into that etcd database.
And then something goes wrong. It always does, right? A server has an issue, there's a bug in the code, whatever, and one of our pods dies. So now the actual state of our world is 2 pods, but our desired state is 3. We have a mismatch. And this, right here, is the absolute superpower of Kubernetes. That controller manager we talked about, It's always watching. It sees this mismatch and immediately goes, whoa, we're supposed to have 3, but we only have 2. So it automatically spins up a brand new pod to replace the one that died. And just like that, we're back to 3. It's self-healing. No pager went off, no one had to wake up at 3 a.m. The system just fixed itself.
Let's make this even more real with, say, an e-commerce website. So, at the very first layer, you've got your pods. You'd have a few pods running the website that people actually see, the front end. You'd have other pods for the back-end APIs that process the orders. And you'd probably have a database pod, which is special because it needs to hang on to its data even if it gets restarted.
Now, remember how pods can die and be replaced? Well, every time a new pod is created, it gets a new unique IP address. You can't give customers a list of IPs that are constantly changing. So what do? We create a Kubernetes service. A service is like a single, stable front door. It has one IP address that never, ever changes, and its only job is to direct traffic to whichever of the front-end pods are healthy at that exact moment.
Okay, one last piece. How does traffic from the actual internet get to our service? That's where the ingress comes in. The ingress is like the main entrance to the entire club. It takes all the traffic from outside, from the web, and funnels it to the correct service. And boom, just like that, we've built a totally resilient, scalable application.
And this really gets to the core of why Kubernetes is so important. It's not just another tool, it's a whole new way of thinking. It's about designing systems that expect failure and know how to recover from it automatically. For developers, this is an absolute game changer. It means you can sleep at night. And for businesses, it means your app stays up even when things go wrong. You're building resilience right into the foundation.
So at the end of the day, Kubernetes takes care of all the messy, difficult parts of running software, the scaling, the failures, all of it. And that frees you up to focus on the one thing that actually matters, writing amazing code and building incredible things. Which leaves us with a pretty cool question to think about. If your infrastructure can basically manage itself, what are you going to build next?